Hi again, I'm here again to talk more about Algebra 1 word problems. I'm still using the Foerster book and still in Lesson 7-10. This time the problem that we're going to talk about is problem 14 in the textbook, and I'll read it off to you right now just in case you don't happen to have the book. The problem states, at a professional basketball game, the turnstile count showed that 17,406 people paid admission. The total cash received for tickets was $133,372 without actually counting the ticket stubs. That would kind of stink. Find out how many people paid for reserved seats at $10 each, and how many people paid general admission at $6 each. We can certainly tell that this is an old book just based off the prices of the tickets to go to a professional basketball game. I've summarized all the information from the problem right here. So this is the stuff that I was telling you when I read it off. First of all, there were 17,406 people who paid admission. The total amount received was $133,372, and that was collected from $10 reserved seats and $6 general admission costs. The first thing we need to do when we think about this is figure out what are the variables that we need in order to solve this. What do they mean? If you listen again, the question is, without actually counting the ticket stubs, find out how many people paid for reserved seats and how many people paid for general admission. So we want to know how many people paid for reserved seats. So how many reserved seats? And we also want to know how many general admission seats. We're going to call the reserved seats X and the general admission seats Y. We could call them R and G if we chose to. That would be fine. But just for simplicity's sake this time, we're going to call them X and Y. Do not ever forget to do this step. Write down the variables and say what they mean. If you forget to do that step, it makes the entire problem a lot harder. Now, I know the problem didn't say that you had to do that step, but do it anyway, and you'll find that the whole situation gets to be a lot easier. Okay, so we know that we want to know how many reserved seats there were and how many general admission seats there were. And we know that the reserved seats cost $10 and the general admission seats cost $6, and that the total received was $133,372. Boy, this is a whole lot of information, right? Well, let's kind of break it up. Let's see if we can use, first of all, this top bit of information. We know there were 17,406 people who paid admission. Those people had to come from two different categories, and those two categories are going to be the number of people who bought reserved seats and the number of people who bought general admission seats. We don't know how many bought reserved seats, so that number is X, and we don't know how many bought general admission. That number is Y. But we know the total number of people was 17,406. So we can say that because X of them were reserved seats and Y of them were general admission seats, that if I add X plus Y, just the number of reserved seats and the number of general admission seats, the total has to be 17,406. So let's do that. X plus Y equals 17,406. Now we have one equation. The problem is that we still have one equation when we have two variables, and in order to get those variables solved, we know we're going to need at least two equations. So the other equation is going to come from this information. We know that the reserved seats cost $10, and the general admission seats cost $6, and that the total was $133,372. $372. Well, how much total was received just from the reserved seats? Well, if I sold one reserved seat, that would be $10. If I sold 2 reserved seats, that would be how much? Hopefully you're saying $20. If I had 100 reserved seats, how much money would that cost? $1,000 for 100 seats? How would you figure that out? Well, you would take the number of seats times the number that, or the amount that each seat cost. Okay? So the total amount received just from the reserved seats, if I had X reserved seats, would be X seats times $10. So 10X. And that would be the amount received just from the reserved seats. So that's the reserved seat amount collected. Okay? But that's not the only place where we got money. Remember, we had a total of $133,372. We also got some of that money from the general admission seats, and those cost $6 each. So if you're really following closely along and understanding everything we're saying, you know that the total amount received just from the general admission seats would be 6 times the number of general admission seats. In that case, this would be 6Y. That's the general admission amount that was received. So since all of this money had to come from either the reserved seats or the general admission seats, if we add those two amounts together, we need to have a total of $133,372. Okay. So now we have our system of equations, because we have 2 of them, and we have 2 variables, x and y. So now we have enough information so that we can figure out what x and y are. Now remember, there are 3 ways that you can solve a system of equation from what we've learned so far. There's actually more, but right now we're just going to talk about our 3 ways of solving systems of equations. The first one is graphing. And hopefully you realize that graphing is not a really great way to solve for systems of equations, at least without some kind of technology to help us out, and we're not there yet. The second way is to use substitution, and the third way is linear combination, or as I like to call it, elimination. In problem number 2, we did elimination. But on this problem, we're actually going to solve with substitution. And substitution works by getting one of the variables all by itself and then substituting that information into the other equation. And you can see in this top equation, it's pretty easy to get one of the variables by itself. I'm going to choose x. I'm going to circle it because that's what I want to get all by itself. And then I'm going to get it all by itself by subtracting off everything else. And what we end up with is x equals 17,406 minus y. And the other equation that we still have is 10 times x plus 6y equals 133,372. Now remember, I know you already have worked on how to solve systems of equations with substitution, but the reason substitution works is that when we have one variable all by itself, we know that that variable is exactly the same thing as this. That variable is exactly the same thing as this. So in the other equation, instead of writing that variable, I can write what that variable is the same as. So instead of 10 times x, x is equal to all of this stuff. Instead of 10 times x, I'm going to write 10 times 17,406 minus y plus 6y equals 133,372. Okay. Now I'm going to use my amazing algebra skills to kind of finish this off. 10 times 17,406 is 174,060. But since 10 is on the outside of those parentheses, I have to distribute. I have to not multiply only by the first number, but also by the second number. So I have a minus 10y plus 6y equals 133,372. Here I have like terms, so I'm going to just copy everything down that I've had before, minus 4y equals 133,372 again. Okay. Now I'm going to subtract off the 174,060 from both sides, minus 174,060, and I'm going to find out that a negative 4y equals this minus that. All right, now I didn't think ahead enough to get my calculator, so let me pull one up on my computer that I'm working on here. Calculator, not calendar. Okay. And there it is. So I'm going to do 133,372 minus 174,060, and that gives me a negative 40,688. Divide both sides by a negative 4, and I find out that the total number, or y at least, is going to be, I'm coming off the bottom again, that y is equal to 10,172. Well, so what? Y is equal to 10,172. What does that mean? Well, let's go back up and think of what that meant. Y is equal to the number of general admission seats. So that means that there were 10,172 general admission seats. Okay. Now, we know that the total number of seats had to add up to 17,406. So we know that x plus y has to equal 17,406, right? And y, I'm going to substitute that back in, was 10,172. So x ends up being equal to 17,406 minus 10,172. X equals, okay, let me type this in, 17,406 minus 10,172. There were 7,234 seats that were reserved. So we solved for both x and y, and we know exactly how many seats there were. Now, to check this, you would take both of these numbers and substitute them back into this other equation. We used this one to solve for x, right? So substitute them both back into this equation and see if you get that 133,372. And I think you will. I'll let you do that on your own time. But let's kind of take a step back and digest everything that we were just learning right here. Again, to figure out the equations, we needed two equations. The first equation, we knew that there was a total number of people of 17,406. So x plus y had to be 17,406. And then we used the fact that the total amount of money collected from the reserved seats would have to be $10 times the number of reserved tickets plus $6 times the number of general admission tickets. And that when we added those two amounts together, we had to come up with the total received there. Each one of these things, 10 times x and 6 times y, is a linear function. And when we add those two linear things together, we're still going to get another linear function. So that works out pretty nicely. All right? So each one of these has a rate, and then we're multiplying the rate by something. In this case, it was $10 per seat. That's a rate. That's just like a slope. And $10 times each seat to give us the total dollar amount. $6 times each y seat. That's another total amount. So each one of these parts of our equation were linear functions that give us, combined to form an even a wider linear function. Okay? I hope you can start to see these patterns and figure out how to put all of the information together to solve the problems. Let's do another in a bit.